Caffeine by Miranda and Hannah. So just a little introduction to caffeine. Caffeine is a stimulant drug, which means it speeds up the messages between the brain and the body. Caffeine can be found in a lot of places, mostly in the seeds, nuts, and leaves of different types of plants. It's also used in the numerous amounts of products that we usually see every day, such as soda, energy drinks such as Red Bull, coffee, and tea. Caffeine is considered to be one of the most commonly used psychoactive drugs in the world, and the effects of caffeine tend to last about 3 hours or maybe less, and it helps the brain and nervous system fight against fatigue or tiredness. It also affects mood, stamina, the cerebral vascular system, and gastric and colonic activity. I'm going to do a little history about caffeine. The word caffeine actually originates from the German word café and the French word café, which both directly translate to mean coffee. Caffeine has been a part of global history for thousands of years, depending on the environment and geographic location you ask. They have different stories about how caffeine came to be used and the source of caffeine, so it varies depending on who you ask. But caffeine was first extracted into its original purest form of white powder from cocoa beans by the German scientist named Frederick Ferdinand Brunsch in the 1820s. The earliest evidence of cocoa being used is documented to an ancient Mayan pot, which is dated to 600 BC. And caffeine's chemical name is 1,3,7-trimethylxanthine, based on its formula C8H10N4O2 and its molecular structure. Okay, since caffeine is very easily accessible, you can buy it in the form of coffee or, like I said, energy drinks, etc. in mostly any store. I'm going to talk about how caffeine is extracted. So there's three main processes of caffeine extraction. There's water extraction, which is where coffee beans are soaked in distilled water, and now when the water, which now has several compounds including caffeine from the beans, flows through a charcoal filter, which removes the caffeine. So then the caffeine from that can be collected and resold for other use in other products. Second main process is the supercritical carbon dioxide extraction, where CO2 is forced through green coffee beans at a temperature about 31.3 Celsius and a pressure above 73 atm. After this, carbon dioxide enters a supercritical state, which allows it to penetrate the beans and dissolve the caffeine inside the beans. And now the CO2 containing caffeine compounds is sprayed with a high pressure water to remove the caffeine, and it can be extracted there. It can also be extracted by organic solvents. Research has been found that certain organic solvents that lower health risks and environmental hazards can also dissolve caffeine. So it is used to dissolve caffeine and leaves the coffee beans decaffeinated.
So these are the neurotransmitter effects of caffeine on the human body. Caffeine acts as an adenosine receptor antagonist, and adenosine is a central nervous system neuromodulator that binds to specific adenosine receptors. Adenosine causes neural activity to slow down and therefore facilitates sleep and dilates blood vessels to promote oxygenation during sleep. Caffeine binds to adenosine receptors without reducing neural activity, and with fewer receptors available to the braking action of adenosine, neural activity thus speeds up. Caffeine also activates numerous other neural circuits and results in the secretion of hormones from the pituitary gland. And then these hormones in turn cause the adrenal gland to produce more adrenaline, which is our fight or flight hormone. With the production of adrenaline, the person feels an extra burst of energy when intaking caffeine, and their attention increases. Caffeine has also been shown to have profound effects on other neurotransmitters, such as dopamine, acetylcholine, and serotonin. That ultimately results in a major boost of our capacities. For dopamine, it increases transmission of the neurotransmitter, which thus improves mood in the person. For acetylcholine, it increases the activity and improves muscular activity. And caffeine also adjusts the serotonin levels, which helps relieve depression and increase relaxation. These beneficial effects of caffeine usually appear when the intake of the drug is relatively low. Okay, moving on to addiction and withdrawal. When a person continues to intake caffeine on a daily basis, the brain cells adapt and grow more adenosine receptors in an attempt to maintain the body's equilibrium with the constant onslaught of caffeine. And thus, with this accommodation, the person builds up a caffeine tolerance over time. Because if there are more receptors, then it will take more caffeine to block a significant proportion of them to achieve the desired effects. The withdrawal symptoms of caffeine also include fatigue, headache, anxiety, irritability, depressed mood, and a difficulty concentrating. There has been some debate whether caffeine is addictive, but the general conclusion is that it usually causes a mild physical dependence, and it doesn't cause the severity of harmful drug-seeking behaviors or withdrawal as alcohol or street drugs do.
And here's our bibliography, so thanks for watching.